Okay, so this gets us to like the most complicated part of the training. Like so far we're talking about, I have a single table. I want to migrate that table to ClickHouse right away. No relation. It's just about types, schemas, conceptual differences, straightforward, right? It's a different tool. You need to change a few things. You need to understand how it works. That's great. But now we're talking about remodeling. We have those relations. How do we change things around, right? As we said, ClickHouse is not a transactional database, not a relational database. So relations in ClickHouse are, we don't recommend them. Actually, you should avoid them. If you need, that's fine. ClickHouse can execute joins, but if you find another way of solving your problem without having a relationship, that's going to be way, way better. So remember, ClickHouse is an online analytical processing. It's efficient for vast data sets and has limited transaction capabilities. Denormalizing is a great way of avoiding having those relationships. You have more performant queries. You pay the price of having a duplicated data, right? Like if you basically add the same username into every single badge, now you have the username like multiple times. But compression in ClickHouse, especially if you're using it as a primary key, works great. So that's not too bad, and it's worth it. Is the data in ClickHouse an auxiliary data, or is it the main data source, the source of truth? If it's the source of truth, all you need to do is migrate once. You do a batch processing, you migrate the data, you forget about the data in Postgres, and now ClickHouse is the only thing that you have. If not, if you need to keep synchronizing, how you're going to do that? You're going to do it every day. You're going to do it every hour. You're going to do like real-time syncs with PeerDB. So take that into consideration. To understand all that, I need to do a detour here, even though I'm running out of time, to talk about how ClickHouse works under the hood. So you do inserts into ClickHouse, right? And every insert you do becomes a part. If you do an insert with 1,000,000 rows, that's a part. If you do an insert with a single row, that's a part. So if you do 1,000,000 inserts with a single row, you're going to end up with having 1,000,000 parts. Not a good idea. There are strategies to cope with that. I'm not teaching you that right now. You just need to understand the concept, not exactly how it works. If you create too many parts, that's a problem. So what happens in the background is parts get merged over time. So we create parts. At some point, ClickHouse decides, oh, let's get those parts. Let's merge them into another part. At some point, the parts are not being used. We get rid of them. We delete those parts. So doing inserts, parts created, parts are merged. Over time, merge parts become merged into a new merge part. Okay, and it just goes in the background. That's how it works. That's what it makes really, really fast. Because the beauty here is that everything inside a part is immutable. So parts, they are immutable files. You don't change them. And that has a lot of different optimizations on the operational system level, right? And how you handle all that, how you need to do locks and stuff, parallel reads, etc. Great. If parts are immutable, if I'm writing, you're creating parts, what happens that when you want to do an update or a delete to a row? What happens is a mutation. And mutations, they're heavy operations. So heavy that we actually change the usual syntax to an outer table. Internally, when you update a row, we actually need to get a part with the row that needs to be updated, and we need to create a new part out of it, right? And if the part is big, 150 gigabyte parts, which are absolutely fine in ClickHouse, we need to somehow rewrite this part. Again, there are optimizations. If files are not touched, we don't need to copy the file. We can just do a hard link but that's internal. It's still a heavy operation. Same thing for delete. If you want to remove a row immediately, we need to get a part and write a new part out of it without that row. We do have lightweight deletes. This is basically going to mark that row as deleted. And instead of doing things at insert or delete time, we actually do at query time. So when you query, we add an extra feature on top of it that's not going to return that specific row to you. Okay? So from a user perspective, it just works, right? But internally, things happen, and we need to understand that to make the best decision. We also have lightweight updates. They are only available in ClickHouse Cloud, so not on the open source. They still use the alter table, but if you have this setting enabled, the rows, they are marked as updated. And again, they are updated actually at query time. So when you run the query, that's when we actually go and put the correct result back. So are rows marked as deleted, updated around forever? No, they are not. Over time, parts will be merged, deleted rows will get deleted finally, and updated will get the final result out of it. But if you're doing that too often, you can just imagine how many things ClickHouse need to take care of now that are actually going to impact your performance. So going to analyzing relationships with that knowledge of parts and how ClickHouse works under the hood. Let's get relationship by relationship and think about it. So votes and vote types, right? Vote types is a lookup table. We just have an ID and a name. Like in ClickHouse, why would you have something like this? How often do you update vote types? Rarely. Okay, then you have your answer. Just denormalize it, get the name from here, transform into a vote type with a varchar, get rid of vote types. Simple as that. Posts and post type, right? Same thing, lookup table, many to one relationship. How often do you update post types? Let's imagine, it doesn't make a lot of sense here, but let's imagine that I update this very often. If I update this very often, then denormalizing it, it's probably not a good idea, because then I need to be updating this too often, and we don't want that to happen. If that's the case, you can have this lookup table within ClickHouse. And the way we recommend is by using what we call a dictionary. So if mutations happen often, use dictionaries. It's a mapping of a key value exactly like this. So you have a key and you have a value, and it's stored in memory, and it can be updated periodically. So you can set up how often this is going to be updated. And it's a very efficient alternative when you're joining two tables. So here's a create dictionary with the post types, an ID, that's the key, that's the value, the post type as a string. In this case, the primary key is the ID. That's the lookup. Notice this is a dictionary. It works different. It's all in memory. The source can be either ClickHouse as a table or a Postgres. So I could have my ClickHouse, instead of looking to a local table, actually go to Postgres and update this dictionary every 10 seconds, every 1 hour, every day, depending on your needs, okay? So you don't need to worry about synchronizing. You can actually have this over there. The layout is how we store this in memory. So documentation can tell you all about the types. Lifetime is how often we go and update this table. And then when you want to query, you can use the good old join syntax, join post types on posts. So let's say I want the ID, the title, and the name. Sorry. You want the ID, the title, and the name. You can do a normal join. The other option is using a dict get. So this is the ClickHouse way of doing a dictionary lookup. You provide the post types, that's the join table. You provide the name, that's what you want to get back. And you provide the post type ID. That's the comparing that you need. Really sorry. Let's look into badge and users. So this is a many-to-one relationship, but they are both very large tables. How are we going to do this? How are we going to keep it? Are we going to keep it as two separate tables and execute a join here? This join is going to be expensive. If you need to, it is what it is. The other option is denormalizing. Denormalizing badges into user, it means you would have like a badges column, probably as an array. And inside that column, you would have all the badges for a user. Some users have up to 19,000 badges. And every time a new user gets a badge, you need to update the user. Definitely not a good idea. Denormalizing users into badges, it's better than the other option, but it depends a little bit. So what data do you really need from the users to answer your queries here? So if there's a query that you're going to use a join, what do you need? Just the display name? Do you need the last access date that's often updated? And how frequently are those users updated? Like this data from users updated within badges, right? If it's too often, then that's also a blocker. Probably if I just need the display name, that's not very often and might be a worth trade-off if you run that query too often. User and votes, very similar discussion, up to 100 votes. So that might make sense because it's not too big of an array. But every time a user votes, you add something to users. That's just too frequent updates. Probably not a good idea. Denormalizing votes into users, same thing. Posts and votes. So both large tables, I could denormalize votes into posts. So have all the votes that a post has in here, an array up to 35K votes, not a good idea. Denormalizing posts into votes, how frequently are these updated? What do you really need? And again, at the end of the day, you have posts and votes linked here for what? Like, why do you need to actually have those things together? If posts are just going to tell you like the up votes and the down votes, you probably have some other strategies to have these votes like separately calculated and then bring it into what you need. So if you look into post table, score, view count, answer count, comment count, those are all analytics columns, right? And they are updated very frequently within the posts. But to ClickHouse, updating is not a good idea. So this would not really perform well within ClickHouse. But if you want to do analytics, to be honest, we don't need all this data. So what you can do is actually move this far away from posts and just have the analytics separately in ClickHouse. Okay? And moving those analytics columns, it's very easy and performant to do with ClickHouse using aggregating merge trees and materialized views. The same thing for users. You have the reputation, you have views, you have upvotes, downvotes. Like we can move this away and just have this analytics data in a separate place. Last access, this is updated very often. So in this case, you would probably need a different strategy, like a replacing merge tree. I think that would be an option in here. Or the best option is probably to keep this in PostgreSQL and just move to ClickHouse, just the analytics part that you need. I don't have a lot of time to cover this, but just to give you an idea of how it works is you're going to create this destination table. This is a special table that we call an aggregating merge tree. It's a table that is very good at aggregating data, right? So every time you insert data into votes, there is a materialized view that gets this data, the same data, and actually already pre-aggregates this and put into the destination table. And the destination table, which is an aggregating merge tree, is smart enough to actually be able to compact all that and do that in a very performant way. Okay, so that's the combination you're going to use. It's materialized view with an aggregating merge tree. You're still going to keep inserting all votes that are coming, all the high volume, high traffic things into this table, and ClickHouse will take care of calculating the rest. There are labs for everything we discussed. Here we have for the vote types denormalization, we have for the dictionary, and we also have for this aggregating merge tree strategy along with the materialized view. I strongly recommend you to go through the labs, to really play with it, to really see how ClickHouse is easy to use and also shines when you're trying to do like analytics, because you have a lot of those functions that just make it very, very easy. There are a few queries in there that you're going to see like the comparison between how you do it in ClickHouse, how you would do it in PostgreSQL. With that said, I want to room to PeerDB folks and now ClickHouse folks to talk about the PeerDB acquisition, how it works, and the CDC use case. So we have here Riyadh. He's in the product team. He works in product integration and really close to like this PeerDB acquisition and the use case. And also Sai, PeerDB CEO. And yeah, very, very happy to have you two here to talk about it. So just go for it.
Hi, everyone. I'll start. I'm Riyadh from the product team in charge of our integrations at ClickHouse. Very happy to be here with, I think, a community of both Postgres and ClickHouse enthusiasts. So that's the perfect audience for what we're going to talk about. And let me just share my screen real quick. I have just a handful of slides, actually, just to support what I'm going to say, but we start with the big news, which is we have new teammates in ClickHouse coming from PeerDB. Very excited about this. Joining forces with the PeerDB team is very strategic to us, and I'll just explain why and what's our thesis behind this move. So I guess with Pablo, you've seen many options for Postgres and ClickHouse integrations already. I'll just dig a slightly deeper here into the CTC use case and what it means for us and why we decided to join forces with PeerDB. So I don't need to introduce both data source. This audience is very familiar with it, but there's a lot of value in both databases and they follow the similar path. That's why we describe them as kind of both sides of the data coin. One is the transactional side, one is the analytical side. However, besides being on the opposite sides of the spectrum, they both share very similar characteristics. They all are like open source rooted. One is row-oriented, the other is column-oriented, address very different use cases, but both widely adopted in their areas and answer really like very strict requirements for the users. So combining both and getting both to work closer towards achieving a use case is what we are after. You can data engineer your way into that integration. You can like use external orchestrator. You can use like built-in capabilities for ad hoc querying. All of these are very powerful scenarios, but the new pattern emerged since many years now, led by Netflix originally, but now everyone is using it, which is change data capture. And the best way to think of it is just plugging the two systems together and keeping the data flow live, active, in permanence. And that really helps simplifying the equation, meaning that in your analytical store, you always have fresh data coming from the transactions, from the source of truth. And this is really like simplifies the integration scheme and allows you to stop focusing on data engineering, but really on answering the questions. And when we started looking into this problem, we've explored a wide range of options, actually. We have our own ETL capabilities in ClickHouse Cloud. It's called ClickPipes. We use it already to integrate with many tools like S3 and Kafka, Kinesis, and other data stores. But when we started looking into the Postgres CDC use case, we quickly understood that it's not that straightforward, actually. It's a hard problem to solve. There's a lot of complexities. You are dealing with Postgres, which is often a critical operational data source that you don't want to slow down or you don't want to hurt while you are like keeping data in sync. And on the other hand, you have latency challenges, you have deduplication challenges, monitoring, freshness, clean failure and recovery scenarios, scalability, etc. That comes usually with use cases that are very natural at ClickHouse operating scale. And we explored a wide range of options and we tested them, and we quickly landed on PeerDB as kind of the leading solution there. From a technological perspective, I think it's a step ahead, and it shares a lot of the common kind of design principles with ClickHouse, with focus on the details, a single data source, Postgres, performance-oriented, reliability and cost effectiveness are two characteristics. So we ran some tests, we reached out to the team, we found out that there's a great cultural fit as well. And here we are today with the PeerDB folks. Very excited to provide this capability. You can go ahead and test it straight away if you want. You can download the open source distribution, run it, and start ingesting data. You can subscribe to PeerDB Cloud as well and send data to ClickHouse Cloud. In a few months, this capability will be merged with ClickPipes, and we will be able to offer it as a service if you don't want to run any infra. But I'll stop talking, make sure to allow more time to Sai to talk about basically what they built at PeerDB and maybe show us some of it. Sai?
Awesome.
The floor is yours.
Thanks, Riyad. Yeah, excited to be here. And in this part of the session, I'll be doing like a quick demo of PeerDB, showing you how easy it is to replicate data from Postgres to ClickHouse. Before I get started, right, like I'll just like preface some premise on how we built PeerDB, right? Like, so just for some context, my background is like prior to PeerDB, I was working at like Microsoft, and I was leading solutions engineering for all Postgres services in Azure. Prior to that, like I worked at a database startup called Citus Data, which built like a distributed Postgres database. So for the past like close to decade now, I've been very much in like the Postgres space, basically. And at PeerDB, what we were building is we were building a replication tool with laser focus on Postgres, right? And we started with this niche of providing like the world's best experience to replicate data from Postgres to data warehouses, right? Which is where like ClickHouse came into the picture. And since we released the ClickHouse connector, there has been a tremendous surge in the number of customers who are using this connector. And the magic sauce is we do a bunch of optimizations on like the Postgres and the ClickHouse side to provide like a 10x faster and a significantly more reliable like data movement experience. For example, we have a feature called parallel snapshotting, which lets you move terabytes of data from Postgres to ClickHouse in few hours instead of days, right? And also on the CDC side, as Riyad was talking about, we do a bunch of optimizations where we always consume the replication slot. And one optimization that we're working on as we speak is consuming in-flight transactions. So as the transactions are happening, we consume them and put it to target, right? So at a high level, right? Like we really double down on, Postgres to ClickHouse replication, right? And with the goal of like building a solution that scales, right? That is very, very important.
Did we lose Sai or is it me?
Hey, everything kind of locked up on my end. What happened? Oh, I think we did
Can
lose
you hear
Sai.
me?
He's back.
Can you hear me?
I thought
Can
it
you
was
hear
my
me?
internet. Yeah, we can. You're back.
Awesome. I don't know why I got kicked off. Okay. Am I live now? I'm assuming.
Yeah, you are.
Yeah.
Awesome.
Yeah.
Awesome. So, okay. So let me, hope I don't click, it says leave webinar, right? Okay. So I have a Postgres database, right? Which has a table called events, right? And then the goal of this demo is to replicate this table in real time to ClickHouse, right? And the table, as you're seeing here, right, has a bunch of like data types. If you see, I also have like the JSON-B data type, right, like which Postgres provides, right? And then you have a primary key, right, as you're seeing on the screen, right? So on the PDB side, like first concept is like there's a concept of peers, and peers are nothing but data sources, right? Like here you have like your Postgres peer and like the ClickHouse peer. Postgres, both of them are running on the cloud and they can run on open source as well, right? Like it doesn't matter. Both of them are running on the cloud though. So prior to the demo, I went ahead and created these peers, right? Like using the UI that you're seeing here, right? Like, so for example, ClickHouse, you can click here and, you can create the peer. And creating peers basically makes PADB aware that, okay, these are the data sources between which you need to kick off like replication jobs, right? So the second concept is PADB has like mirrors, and mirrors are nothing but replication jobs, right? They are responsible for replicating data from Postgres to ClickHouse, right? And then there are different types of mirrors. First is the CDC-based mirror, which uses Postgres's write-ahead log, and it uses logical replication under the covers to replicate data from Postgres to ClickHouse. And under the covers, it takes care of both DML and DDL replication, which is, inserts, updates, deletes, and also DDL, where like you add columns, right? All of that is supported with CDC, and it relies on like the Postgres's write-ahead log. The second type of replication is the query-based replication, where you can run any query on the Postgres side, right? It can be a join, it can be a simple query, etc., and replicate that query based on a watermark column, right? So you can specify a watermark column that like, okay, I have an updated at or a created at or an incremental like ID column, right? So you can think of this more like batch-based replication. So that is also available in PADB, right? As a part of this demo, I'll just be showing, the CDC-based replication, because this is more native, where you use the write-ahead log, etc. You can use query-based replication when you don't have primary keys, or you have more like a batch and a non-real-time kind of a workload, right? But more the standard one is CDC, which is change data capture. So let me call the mirror as Postgres to ClickHouse CDC, right? Select the source peer, which is Postgres, select the target peer, which is ClickHouse, right? And then there are a bunch of configs that you're seeing on the screen. First is the sync interval, which says 60 seconds here. I'll change this to 10, which means that the real timeness on the target side, right, is 10 seconds, right? So data is like 10 seconds old. So it's like pretty fresh, if you're seeing. And then there are other settings like parallelism for initial load, right? In CDC-based mirror, there are two steps. One is the initial snapshot, where existing data is copied onto ClickHouse, right? And second is the continuous CDC, where like as inserts, deletes, updates are happening, those are replicated in real time to ClickHouse, right? And this setting here configures how fast you want to do the initial snapshot of data, which is you can configure the parallelism to like 4 or 8. I'll just leave it as default, right? The advantage of this is initial snapshots are very fast. So like we have seen customers move terabytes of data in few hours instead of days. So recently we did, one of the customer moved 3 terabytes in 12 hours, right? Which is pretty quick for that scale, right? And there are a bunch of other settings which I won't go into, but one fun setting is in CDC, you can also do row level transformations, basically. And you can specify Lua scripts and specify and do row level transformation. Say you want to mask columns, or you want to, add a generated column, you can do that as well. I'll slightly touch upon this script piece in the next, as I go into the demo, but I'll skip this for now. Okay. And then now I'll choose the table. So the table I'm doing is like public.events, which has around like million rows, right? And you can specify what name you want on the ClickHouse side, right? And let's go to the ClickHouse side and let's quickly run this query. And if you see, the table does not exist, right? I've not yet kicked off the mirror, right? So let me, I specify the name and let me validate the mirror. Okay, so the mirror is validated, and let me go ahead and kick off the mirror, right? Okay, so the mirror has been kicked off, and let's give it like a few seconds. It will come up very soon. And in the meantime, I'll show you like, other parts of the UI, right? So we provide logs, which shows you, what are the logs in the system. There are alerts that you can configure, right? And the alerts are related to two main like metrics. One is the slot lag threshold, which is the replication slot size, right? So you can say that, hey, if my replication slot size is over 50 gigabytes, then send me an alert, and that alert can be to either Slack or email, right? Or the second is number of connections on the source, right? And the idea here is like, this is more useful when you're running query-based batch replication, right? Like where you have parallel queries running on source and you want to get alerted when the number of connections used by PIDB are higher, right? So that is also available. And then scripts is like a fun tab, which, you can create like, transformations, as I talked about, right? So you can create like Lua scripts saying that, hey, as the data is moving, I want to mask columns. Say I have my SSN or PII related data that I want to mask. So you can write a simple Lua script and then plug into the mirror, right? Like if in the mirror, if you remember, there was like a scripts input, right? So you can do that as well as a part of CDC. Now let's go to the mirror and let's see whether it's ready. Okay, so let's check the initial load, and looks like the initial load finished, right? So of 1 million rows, and it took 9 seconds. So that was pretty quick, right? Now let's go ahead and run the count. And 1 second, the Zoom thing is blocking me. Okay, 1 second, I'll move this here. Let's run a count. Okay, and then if you see, now it should have 1 million rows. Should come up soon. Should have 1 million rows, as you're seeing on the screen. Previously, there was no table, right? So PIDB under the covers took care of creating the table, did the right like data type translation, and ingested the rows, right? Let me go ahead and refresh this page, and like we'll also see the preview of rows, right? So this public.events got created, and here you're seeing preview of rows. For some reason this is not showing, but let's go to the untitled query, and then like to select star from public_events, limit 10, right? And then they should pop up. Okay, now the next step, what I'll do is I'll start ingesting data into Postgres, right? So where I'll ingest around 1,000 rows every 2 seconds, right? So which is around 500 rows per second, right? I'm ingesting rows into the events table. Now let's go to the PIDB UI, and let's see what's going on the sync status tab, and let's refresh this. Okay, so the first batch is done, 5,000 rows. Let's go to ClickHouse and run a count. Yeah, so the data is there. The count has changed as you're seeing here. And then as data is getting ingested into Postgres, that is getting ingested. It's also being replicated to ClickHouse, and the real timeness is around like 10 seconds, right? And let's like check whether the count has changed. Awesome, right? If you see, the count has changed. I want to do a fun thing now. I'll go ahead and add a column to the table, right? This is to show DDL replication, right? So here, what I'm doing is I'm adding a new column to the events table, which is the IP column, right? Let's go ahead and add that column, right? If you see the events table now, it has the IP column, which is a text, right? Now, what I'll do is I'll go ahead and insert that IP data as well. So if you see here, I'm adding a new field, which is the IP, and I'm adding 127.0.0.1, and I'll start ingesting like data, right? So now let's go ahead and see whether this particular column is getting replicated to ClickHouse. So let's give it a second. In 10 seconds, it should be there on the ClickHouse side. So let me run this query. Awesome. So the IP column, which previously was not there, got added to the ClickHouse table. Let's go ahead and check this these rows, right? Let me count, and if you see, the IP column has gotten added here, right? So yeah, so like PaDB also supports like DDL based replication as a part of CDC, and now it also supports like updates and deletes, right? So as they happen, and under the covers, like we use replacing merge trees on the ClickHouse side. So that is the table engine, right? So updates and deletes as they happen, we put them as inserts and leave it to ClickHouse for asynchronous deduplication, right? And the deduplication is based on the primary key, which is the order key, right? And the version. So every row, like we create a version and send it to like ClickHouse, and ClickHouse magically, does the deduplication, right? So that way, we support like inserts, updates, deletes, and also DDL commands like adding columns. So you get some like, cool metrics also, as you're seeing on the screen. So, okay, number of inserts, number of updates and deletes, what has been the throughput over time. So if I go to, right, like, so I'm constantly ingesting. So you're seeing that as well, right? And yeah, and that was the demo. And like one thing I do want to call out is everything that you're seeing on the screen, right? Like via the UI can be done via a Postgres compatible SQL interface, where the idea is you can script out all your mirrors and replication pipelines very easily. And the advantage here is, say you have like tens of Postgres databases that you want to replicate to ClickHouse, you can use the SQL API to create these peers, mirrors, right? Like manage these mirrors very easily. So you can script all of them out. So yeah, that's it from my side, and looking forward to take some questions.
Great, that's great. Firsthand, that's really, really nice. Thank you for joining, taking the time. And yeah, I think there was some questions in the chat, but I think we had covered all of them.
Yeah.
So if folks have any other questions.
Is it possible to remove or hide extra columns that come with PaDB? Yes, it is possible. It is possible. I don't know whether Riyadh knows that recent feature, but it is possible. So let me share my screen. So if I click on new mirror, right, like, and it should be possible, at least for Postgres to Postgres, we did that. In an advanced settings, there is a column called disable all PaDB columns, right? So this, you can enable, right? And this would like remove the PaDB specific columns also. So it will be like mirrored exactly to the target. So FYI guys, like this is all built based on customer feedback. So like, I mean, there was a request where like customer needed this, right? Like, so we added this feature, but that's also, supported. And we added this just like last week. So. Yeah, what happens if data is inconsistent between Postgres and ClickHouse via PaDB? Yeah, so that's a great question. So so firstly, like, I mean, data being inconsistent is very, very, I mean, it's not like possible. The reason is because we rely on replacing merge trees, right? Like, and we guarantee that there is no data loss, basically, right? because we keep the last committed source LSN, right? And if there is like, if the pipeline fails, right, like we have automatic, like we have a state machine which auto recovers and continues from the last committed source LSN, right? So, and the deduplication is taken care by the replacing merge tree, right? So there cannot be scenarios where data is inconsistent on the source and target, but sure, there can be bugs, right? Like, I mean, it's finally software. In that scenario, like, there are a couple of approaches you could follow. First is you basically, we have like a raw copy of the data in a raw table, which is like more internal to PeerDB, right? So you can use that table to do the reconciliation, right? So that is one approach that requires some of our intervention also. So we can help you as needed. So that is one where like the entire raw feed of the CDC is copied as raw tables on the ClickHouse side. There is a single table per mirror which captures all these changes. So you can use that to do the reconciliation, or you do a resync, right? Like, so PeerDB also has an option where you can resync the entire like mirror. And let me show that also. So in the mirror tab, right? Like, so if you go to the mirrors, you have like actions where you can, resync the mirror, right? So you just resync the mirror and we take care of like an upsert on the target, right? Like, so that, I mean, upsert in the sense like your data will be there and like we do a switch, we do a full entire like move, and then we do a switch of like tables, right? So the entire data is again copied. So two options. One is you lean on the raw table that is present. So those raw tables, if you're seeing here, these are the raw tables that we created, as you're seeing here. You lean on the raw tables to do the reconciliation. This requires some surgical intervention which might need our help, or simply you just go to the UI and do a resync, right? Like, and under the covers, like again, the initial snapshot, everything will be fast because we have optimized for that.
Just wanted to
we're
add
running. Yeah, go on. Sorry.
Something real quick on the replacing merge tree and its importance. I really like, if you're interested in this, like syncing large data sets to ClickHouse, I really urge you to like explore replacing merge tree and how it works. It's actually a very interesting model. It relies on basically the fact that the merges are when the duplication happens, and pushing back this workload into an asynchronous process allows basically ClickHouse to scale. So it's a very interesting model. It's actually the, I think, only scalable model to deal with this problem at the terabyte scale. And I think it's great. And whenever you need exact result, you can add the final modifier to your SQL queries. And actually, this final modifier will make sure to include the latest updates there. It's a bit slower than without the final, but this actually has been greatly improved in the last quarters by the core team and contributors to the ClickHouse core project. So I think replacing merge tree is a great tool, and I really believe that it's the only way to achieve deduplication at scale in ClickHouse.
Awesome. So there are a couple of questions. First is like, if you see new columns in upstream source table, will it reinsert all existing rows as inserts? And then it's up to ClickHouse for deduplication, right? So alter table, like add column, right? Like, so when you add new columns and then you keep ingesting new rows, right? Like that is replicated as is, and we replicate them as inserts, right? Like, and then if there are updates also, we replicate them as inserts and leave it to replacing merge tree to do the deduplication, right? Now, one very good question there is like, if you add a default column, right? If you have a column with like a default like value on the Postgres side, right? That by default is not supported, and the reason is because logical replication does not give you those values yet, right? Like, so for that case, typically what customers do is they either like run that update or the batch update on the target side, basically, or do a resync, right? So two scenarios. One is like, adding column, new rows are automatically replicated, right? Adding column with default, the data in the previous rows, right, where you are updating those rows, that for supporting that, you need to run like an update on the ClickHouse side, a batch update on like the ClickHouse side to update the existing rows, or you do a resync. And the reason there is because logical replication has some issues where like it still doesn't give you like rows when you change the default of a column, basically. So, yeah.
The last question is similar to another one that I think we skipped. It's like, how do you, using PeerDB, can actually manage like the mapping and like the column level, for example, compression and stuff? So what is the granularity that you can do?
Good question, right? So what PeerDB does is we create the table and then if the table does not exist, right? So, and the way we create the table is there is a data type matrix, right? Like, so for PostgreSQL and like you see ClickHouse here, right? And then there is a data type matrix like which we use under the covers, right? And it's kind of also, you know, for example, arrays, right? Like we put it as arrays, right? So we lean on this to create the table on the target side if the table does not exist, right? But you can yourself create the table with whatever compression mechanism, whatever order key, right? And in that scenario, PeerDB doesn't like create the table. It checks, it creates only if it does not exist, right? So we use create if not exists, right? So the short of it is the compression and the ordering, etc. For the columns and the data modeling stuff on the ClickHouse side is something that we leave it to you, and we just like see the table and start replicating basically. So if the table exists with the right data model, we don't touch it, right? In the future, like we are working on enabling customers specify like order keys and like compression algorithms for like columns out of the box, where like while creating the mirror itself, you can say that, hey, these, you know, you can, this is the order key, this is the compression algorithm, etc. And under the covers, we take care of creating the table and all of that, right? But it, as of now, it's not a blocker because you can have your own table, you can have your own table with the same name, and PDB doesn't change anything. It just puts it into the final tables.
Yeah. This is absolutely great. Like, thank you very much again for joining. Thank you, everyone. Unfortunately, we ran out of time. I'm sure everyone has way more questions to ask. Here are a few pointers. Like, go check our Learn page. I didn't show it all, but if we go to, I think I closed it. Yeah, to the course, you can actually look into the free courses we have. So one of the free trainings we do have is what Riyadh was talking about, which is the deduplication one. So if you check, I think it's this one. What else? Slack, we are all in Slack also for the training stuff. So if you have questions about the training, we are there. There's the ClickHouse Academy. Otherwise, just help, and we try to hang out there. And yeah, I think there is a reference, so you'll find the links to like all the data set if you want to play with the data set yourself. Otherwise, just start a cloud account. And I do want to share one last thing one more time, if Zoom allows me, which is the link. Here's the link for the recording will be there. The labs are there. Everything is there. So again, thank you very much for joining, and yeah, see you around. Bye, everyone.
Bye.